Okay, so here's either supplemental problems or review for section 8.1. It's basically geometric mean, which we'll talk about later, and then these two theorem problems that deal with the geometric mean. So, the first one, this was number 5 we did. The altitude. The altitude itself is always the geometric mean of the two parts it forms in the big hypotenuse. Okay. So x is always, if you're looking for the altitude, that's always the easiest one to find because it's just going to be the geometric mean of those two portions. So x equals the square root of 3 times 12. Well, the square root of 3 times 12 is the square root of 36. X is 6. Okay. Now the next two theorems deal with legs. And a leg of the big overall triangle is the geometric mean of the small adjacent side and the whole hypotenuse, which is 15. So y equals the square root of 3 and 15. Okay. Well, that's the square root of 45, which we don't leave it like that anymore. This is the annoying thing about this chapter, so we're going to have to break those down. So 3 and 15, 3 and 5. Hey, a pair of 3's ends up being 3 root 5. Okay. Now, z is the exact same theorem. You're using the leg. The leg is the geometric mean of, again, the part next to it, the 12, the part of the hypotenuse next to it, not the whole hypotenuse, but then to the whole hypotenuse. So z is the geometric mean of 12 times 15. Now, I showed you in class, you can multiply that, it's 180. But here's another shortcut. Break down 12, which is 2 and 6, 2 and 3. Break down 15, which is 3 and 5. And now go looking for pairs. Here's a pair of 2's. Here's a pair of 3's. Root 5's left over, so z is 6 root 5. That's the most straightforward way of doing of those theorems, that the altitude is the geometric mean of the two parts, and that the leg is the geometric mean of the one part adjacent to it and the hypotenuse. Adjacent to it, hypotenuse. Now, where they try to get a little fancy at is a problem like we did in class. It was number 6, where, okay, now when I look at this, I already have the altitude. I don't have the two parts of the hypotenuse. So, when I break this up, the altitude is the geometric mean of this part of the hypotenuse and this part of the hypotenuse. So we'll still solve for x first, but now we go to solve for x. Okay, 16 is going to be the geometric mean of 8 and x. Okay. So that gives me then 16 is the square root of 8x. To solve for x, undo a square root by squaring it. 256 equals 8x. Divide by 8. That ends up being 32. Okay. Now that's important for us because if I tried to do the theorem with, the leg is the geometric mean of the part next to it, which is the 8 in this case, and the whole hypotenuse. Well, in this case, that's 8x plus 8. That's two variables in one problem. I can't do that. But now they know x is 32. Hey, that's 40. So now to solve for z, z is the geometric mean of the part adjacent to it times the whole leg, or the whole hypotenuse. Again, you can multiply this together and make it 320, but it actually makes it a lot easier if you break down the 8 and the 40. And in fact, here's another advanced technique. 40 is 8 times 5. So I have a pair of 8's. I have that root 5 left over. There's z, 8 root 5. And then we do the exact same thing for y. Because the legs, the order doesn't matter. Once you know the parts of the hypotenuse, you can do z or y. But you had to solve for x first. So now y is the geometric mean of 32 and 40. And again, there's a little trick in here. 32 is 8 times 4. 40 is 8 times 5. Break down the 4. It's 2 and 2. And what we actually end up getting then is pair of 8s, pair of 2s, and then 5 left over. So y was 16 root 5. Okay. All right, now the last problem then is again the kind of a straight up geometric mean problem, a little bit of an application. It was number 31 in the book. So it says the geometric mean of a number, well, we'll call that number x, and 4 times the number, okay, 4x, is 22. What is the number? Well, the geometric mean, which is 22, okay, is the square root of the number times the other one, and that's what we're going to solve. So I will simplify that. 22 equals the square root of 4x squared. And at this point you could square both sides, but they did this on purpose, that 4 and x squared both have square roots. Square root of 4 is 2, square root of x squared is x, and now divide by 2. 11 is x. So the number is 11, and 4 times itself is 44. Okay. So again, if you were in class, it's just hopefully a little brief review. If you weren't in class, hopefully that gave you an idea, and if there are any of those that didn't make sense, come on in and we'll go through them together a little more in depth.